Hello and welcome to Ed School everyone. Today we are going to understand about oxidation state in fraction. That how could the oxidation state be in fraction? But before that, in the previous video or the previous part of redox reaction, I have given you two questions to do at home. If you were able to do it, very well. But if you are not able to do it, kindly look at how to do it. So over here there is Cr2O7 2 minus. What am I going to do is I'm going to find the oxidation state of Cr. I will consider its oxidation state to be X. As there is not only one Cr, there are two, so I have to say 2X. Twice of that oxidation state. Plus there are 7 and then oxidation state of oxygen is nothing but -2. And the sum of all the oxidation state in this complex compound will be equals to -2 because that's what the charge which is present on it. If I will solve it further, I can write it as 2x minus 14 is equals to -2. And if I want to find the value for x, it is nothing but, or first let's say, I will just write one more step, -2 plus 14, and x will be equals to nothing but 12 by 2, which will be equals to 6. Hence the oxidation state of each chromium in this complex is nothing but +6. Let's move to the next element. If you understood how to solve this one, it would be comparatively easier for you to do the next one. Let's suppose that the oxidation state of the sulfur is nothing but X, and for that of the oxygen is 4 2 minus, and the sum of the oxidation state of it will be equals to nothing but -2 because the charge on this complex is of -2. Let's solve it further. So it will be x minus 8 is equals to -2. I could write it further as x is equals to -2 plus 8, and hence x is equals to +6. In this case as well, the S has the valency of +6, and that's how we solve it, and these are the answers of it. Now let's understand the oxidation state in fraction. Then how could the oxidation state be in fraction? See, what happens is that it is not possible that the person is giving half of the electron, or they are giving 3/4 of the electron, such that they will be having the charge of 3/4 or 1/2, or over here as you can see the oxidation state of 4/3. So it's not possible that they give 4/3 electron, right? Not possible. Charge is an integral unit, so it could be given only 1 electron, 2 electron in the integral multiple of it. It's not possible to give half of the electron and all. Then how come the oxidation state be in fraction? See, what happens is that the oxidation state is distributed amongst the element, or we could say we distribute among the element and then we find the mean of it, that what could be the average charge on each atom. Let's understand with the example, otherwise it would be confusing to understand. So see over here, what is going to happen is, this is carbon suboxide C3O2. There are 3 carbon elements and 2 oxygen, which you can see on the screen. You see this carbon has the valency of +2 and this has oxygen has -2 as usual. Not as usual, but mostly. And over here it has -2 and +2. You see the central atom that of carbon has no oxidation state as like it does not have any charge on it. The charge on it is 0. It's a neutral atom. Then how come the charge, or how come the oxidation state is 4/3? See, if you will talk about each carbon specifically, then the valency of this carbon, or I should say, then the oxidation state of this carbon is +2, of this it's +2, if you will see individually. While if I want to find the average charge on per carbon, then how do we find the average charge on each carbon divided by the number of carbon atoms I have, and that will give me 4/3. So don't get confused whenever the oxidation state and fraction comes up. It's very simple, that you first find that what is the charge on individual atom, and then find the average of that atom. How will you find the average? Charge on per atom divided by the number of those atoms. So in this case, C3O2 will be having the charge of 4 by 3 on them. That's how we find the oxidation state and fraction.